Hello, this is Mr. Fedorov. Today we're going to be talking about Texas Standard 7.5a. And this is a topic about matter and energy. And what we're going to be discussing today is we're going to be expecting you to identify that organic compounds contain carbon and other elements such as hydrogen, oxygen, phosphorus, nitrogen, and sulfur. So today we're going to be talking about organic chemistry. Okay, I'm going to talk about what we already know or what we have learned here from 6th grade. First thing we have learned is that elements are the purest substances on the planet and in the universe and are represented by chemical symbols. The second thing we have learned in 6th grade was that the periodic table shows a list of these elements with represented symbols. So when we look at the periodic table, and you'll see one today when I talk about this, that they're represented by symbols. Finally, we learned in 6th grade that compounds are two or more different elements that are joined together. So those are the things that what we already know, and next we're going to talk about what we have learned. So what we're going to learn. So what I hope you're going to learn from this lecture is that you're going to learn how to identify an organic compound. You're going to be able to understand how organic compounds are generally produced. You're going to understand what elements are found in organic compounds, how to recognize an organic compound's chemical formula. So we're going to talk a little bit about what a chemical formula is, and I'm going to reinforce the differences between elements and compounds and the differences between those two. Organic chemistry. Organic chemistry, well, first of all, I'm going to talk a little bit about what is chemistry. Chemistry is the study of matter. And matter is anything that has mass and occupies space. It's anything and everything around us that is physically present. It can be a solid, a liquid, a gas, or even a plasma when we look at, say, fire. So a lot of these things, chemistry is really the study of that and how these different types of matter interact. Organic chemistry is the study of specifically the carbon atom and how that carbon atom kind of relates to life. When we're looking at organic chemistry, it's really the study of the carbon atom and compounds that carbon can make in relation to life processes. So when we're talking about organic chemistry, we're really leaning more towards life and the study of this carbon atom. And carbon is one of the elements on the periodic table. So let's take a look at the periodic table here for a second. So here we have a periodic table of elements, and these are all the elements that are known in the universe. This is kind of an alphabet soup, so to speak, of our universe. These are all the different kinds of atoms that exist to make up our universe. And these can come together in various combinations to form different things. For example, we have hydrogen up here, and then we have oxygen over here. Now separately, hydrogen and oxygen are both gases at room temperature. We breathe in oxygen constantly, and hydrogen is all around us. But when I combine the two, oxygen and hydrogen, I get a totally different substance. That's a compound, and that compound is called water, the stuff that we drink. And so these atoms, or these elements, can come together to form different things. Carbon, right here, is the element that we're talking about. That element is the focus of organic chemistry, and it is what carbon binds to and combines with to form other compounds that we study in organic chemistry. So when we're looking at this carbon as an element, we are going to be studying the carbon atom, but we're also going to be looking at more specifically organic compounds. And so there are some criteria that we look at to identify when compounds are considered organic. Criteria means they're kind of like rules. So these are rules that we generally use to identify organic compounds. The first one is an absolute must. It is that it must contain carbon. So the element or the compound has to have carbon in it. The second one is that the carbon must be connected to a hydrogen atom. So hydrogen has to actually be present as well. So those two are really critical in organic chemistry and in organic compounds. So you note here on the side I have a little square and carbon and hydrogen sideways. Those two are a must for it to be an organic compound. The last part is more of an understanding that it's generally related to a life process. So most of your organic compounds come from life, and that's really what we're studying here. Is we're starting to learn about life in 7th grade science. So, what other elements are common to organic compounds? We're not just going to see carbon and hydrogen. These two are very important, carbon and hydrogen, but we are going to see other elements as well. We're going to see elements such as sulfur, nitrogen, oxygen, and phosphorus. So a combination of these elements will probably show up with carbon and hydrogen. The most common one is actually oxygen. We see carbon, hydrogen, and oxygen very frequently showing up together in organic compounds. And we'll see that when I talk about glucose next coming up. So the first thing I want to do is learn how to memorize or remember this. And we've come up with a way to remember organic compounds and all of these additional elements. So how are we going to remember all of these elements? That's the first question. Well, there's a mnemonic that we remember, and that's all organics eat at sponge. Now, the sponge is in all capital letters, and each one of those letters represents a chemical symbol. If we take a look back at our periodic table, we can see that S would represent sulfur, and P stands for phosphorus. The N, it stands for, or the O, it stands for oxygen. A capital N stands for nitrogen. A capital C stands for carbon, and a capital H stands for hydrogen. And I have little dots above these two saying that these are the most important right here for the atom or the molecule to be an organic compound. So what are some examples of organic compounds? Well, the first one that we talk about are carbohydrates. Carbohydrates are sugars, essentially, and one that we're going to study a lot this year in 7th grade is glucose. Glucose is a sugar that's produced by plants, and we end up actually eating that sugar or stealing it essentially from the plants. So what does that molecule look like? Well, you'll see here that I have 6 carbons. They're all connected to each other. The carbons are in red here. And then I have several hydrogens that are attached to the carbons. And those two are connected. And we do also see the oxygen. So here's our CH, which is so critical for an organic compound, but we do have the addition of oxygen right here in sponge as another element that's part of this organic compound. So this structure right here is the structure of glucose. Now this is in straight chain format. There are other forms of glucose, but this is what it basically looks like. We also have fats and proteins. Those are both considered organic compounds as well. And so you might see a fat or a protein, but I'm not going to draw the chemical structure. All you really need to remember when it comes to this is sponge, that it contains sulfur, phosphorus, oxygen, nitrogen, most importantly carbon and hydrogen. So how are organic compounds generally formed? Well, if life forms them. Life makes organic compounds. The example up here of glucose is made by plants. Plants make glucose. And so what they do is they actually take in carbon dioxide, which is from the air, and water from the soil, and they do, in the presence of sunlight, they'll make sugar or glucose, which is right here. They actually form this compound. And so instead of always writing glucose like this, we have a way of writing it in shorthand. We write a chemical symbol for glucose, which is shown right here. This is a chemical formula, or not a chemical symbol, but a chemical formula for glucose, C6H12O6. And so this whole thing is considered a chemical formula. And what I'm going to kind of describe what this chemical formula means. We have here in a box the carbon atom. That is one element. We also have hydrogen, which is another element. And we also have oxygen, which is another element. So I have essentially 3 elements here. But I also have these little subscript numbers, and that tells me the numbers of atoms. And those numbers can tell me that I have 6 carbons, so you'll notice up here, 1, 2, 3, 4, 5, 6. I've got 6 carbons. I have 12 hydrogens, so I can count the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I also have 6 oxygen atoms, 1, 2, 3, 4, 5. Oh, I'm missing one. Oh, there should be an O and an H right here. It should be 6. It should say O and H. So there's an error right here in the structure of glucose. So there should be 6 there, and that would be a glucose molecule So altogether, this is a chemical formula, and we are going to move on now and try and identify some different types of organic compounds. Okay, so the next question is, can you identify which compounds are organic? And so we have a whole list of organic compounds here, and we're going to try and identify which one of these is organic and which one of them is not. So we're going to start with the first one, sodium chloride. This is commonly known as table salt. And so my question is this an organic compound? Well, table salt does not contain carbon or hydrogen, and you remember that carbon and hydrogen are absolutely critical for it to be present in an organic compound. So this one is not an organic compound. The next one, C6H12O6, this is glucose. And you'll notice here that we have our carbon and our hydrogen right there. So that automatically tells me that this is an organic compound. Next is CH4 or methane. This is an organic compound because, again, it has carbon and it has hydrogen, so I know this is an organic compound. Sodium hydroxide, or NaOH. This is not an organic compound because, again, it is missing a carbon. Carbon dioxide, CO2. This is not an organic compound. It is missing a hydrogen. Remember, carbon has to be attached to hydrogen in order for it to be an organic compound. Next we have water, H2O. This is not an organic compound either. Water does not have the carbon atom in it, so it is missing that carbon atom, and therefore it is not an organic compound. Ammonium hydroxide, NH4OH. This is also, again, missing the carbon atom, and so we do not have an organic compound here. Finally, we have our last two. Both of them have a CH, and I can circle both of these CHs, and they both are considered organic compound. And the dead giveaway is, when you look at these, if you can go and circle the CH in front of it, then that's going to tell us that it is an organic compound. So you look up here at this list, if I can circle the CHs in front, it's a dead giveaway for an organic compound. Again, you have to remember that sponge, we might see situations where sulfur, phosphorus, oxygen, and nitrogen are present, but the main one is the CH and identifying that it has a carbon-hydrogen bond there that makes it an organic compound. Remember that all elements start with a capital letter. Commonly, one of the things that people commonly mix up is the C and the L. They think this is an I. If this was an I, it would have little, it would look like a capital I. This is clearly a CL. So remember that every time you're looking at something, you look for that capital letter to identify the element. And finally, again, when you have two or more different elements that are connected, they are going to form a compound. So for example, here I have carbon and I have oxygen. The two of them are different elements, and together, when they come together, they form something called a compound. So now that we're done with this lecture, do you now know how to identify organic compounds? Do you know that when a compound has carbon and hydrogen in it, that it's generally going to be an organic compound? Do you know how organic compounds are generally produced? Life produces it for the most part. There are organic compounds out there that are not produced by life, but for the most part, life produces organic compounds. Do you understand the fact that there are elements besides hydrogen and hydrogen and carbon, that are present in organic compounds? Nitrogen, oxygen, sulfur, and phosphorus can also be found in organic compounds. Or the term sponge. Do you remember that? Do you know how to recognize an organic compound's chemical formula? So when you look at a chemical formula and you see that CH, that should be a pretty big automatic red flag that it's an organic compound. Finally, do you understand the differences between elements and compounds? Remember, elements are just the chemical symbols. They're the purest form of the substance. Compounds, on the other hand, are two or more different elements that come together to form a totally new substance, and in many cases, a compound. So hopefully you've learned all of that. You now have mastered Texas State Standard 7.75A, which expects you to identify that organic compounds contain carbon and other elements such as hydrogen, oxygen, phosphorus, nitrogen, and sulfur.